I'm David Wagman, editor of Power Engineering Magazine, and we're in Pittsburgh, Pennsylvania, site of CoalGen 2010, the 10th anniversary for CoalGen. Earlier in the week, our videographer, Alex Bradley, went out to Consol Energy, where he caught up with Steve Winberg, the director of research, for a tour of their research facility looking at clean coal technologies. What is so important at CoalGen throughout the week has been discussions on emissions control and clean coal. So the work that is going on at Consol Energy is very relevant to a lot of the topics that were being discussed here in Pittsburgh this week.
David, welcome to Consol Energy's Research and Development Center. We're located just south of Pittsburgh, Pennsylvania. We have an 88-acre campus here, and it's a beautiful day today. What we do here at Consol Energy R&D is research as well as analytical work. We do research projects, as one might expect. A lot of those projects are focused on greenhouse gas reduction with potentially pending climate change legislation. So we're focused on reducing greenhouse gas emissions from our coal mining operation and also from the combustion of coal. So we're quite excited. A lot going on in fossil energy these days, and we'll walk through a little bit of our lab and then on down to our pilot facility. We're standing in Consol Energy's Research and Development Laboratory. We're in the lobby. Consol Energy is the largest producer of bituminous coal in the eastern United States. We're also the largest reserve holder of Marcellus shale here in Appalachia, or in the eastern United States. What we do in this coal lab is we do analysis on coal, water, biomass. We're also doing analysis on mercury emissions from coal-fueled power plants. And what we plan to do now is we're going to take a walk through our coal lab and our water lab. So come on with me. This is our coal analysis laboratory. We also do biomass in this space here. With respect to coal analysis, we do heating value, moisture, sulfur, ash fusion temperatures, all of the analyses that are needed by our customers to know the type of coal that they're purchasing for us and the impact that it will have in their facilities where they're burning it. This is Dave, one of our senior technicians, and he works quite a bit in this coal lab. We're going to walk through this space here and into our water lab. This is the water analysis lab. We do water analysis from our mining operations as well as our gas production operations. You can see lots of bottles of water here. We do a whole battery of tests on these waters. We're also doing work more and more for external customers. So not only do we do analysis for our own operations, but also for outside companies, other gas companies, other coal companies, and a whole variety of other customers. This space here is where we do trace analysis. More and more of our customers want to know what's in coal, what's in the water, what's in their stack emissions, and we're dealing in parts per million or even parts per trillion. So we use some rather advanced technology to tell them exactly what it is that's in the ash or the coal, or in cases of our mining operations, we do lube oil analysis. And in the mines, that's a pretty harsh environment for equipment, for big gearboxes and motors and so forth. So we have a very aggressive preventative maintenance program here. We do oil analysis, and what we can determine with that oil analysis is exactly what's going on inside that rotating piece of equipment. It's very similar to taking a physical and having blood work done. Doctor can tell a lot about what's going on inside of you when they do blood work. Same holds true with oil analysis. These white bags here are pulverized coal, and this is not really an R&D project that we're working on, but rather it's a tolling service. Various customers need to have their coal pulverized, and so they bring it to us, we pulverize it for them, we put it in these bags, put a nitrogen cap on it, and send it off to wherever they need it. It's a little bit of a side business that we do to help support our research habit. We're entering the pressurized fluid bed combustion control room. Morning. This control room is for the PFBC technology. It's a fully automated 1 megawatt test facility, and we burn coal here, and then we take all of our pressure and temperature measurements throughout the unit, as well as emission monitoring. We operate this unit for about 72 hours at a stretch, and the purpose of doing this is to get the parameters under which we would design and build a commercial sized facility. So we'll take a waste coal, we might take waste biomass or sawdust, we mix it together, we burn it, and we develop a lot of data which then can be used to design and build a commercial scale unit. These units will come in about 100 megawatt modules, and this technology was originally designed here in the United States, and then it was built over in Europe. They built several plants, one in Sweden, one in Germany. They have a large plant in Japan, and we think it's time to bring this technology back to the United States because, again, it can burn a wide variety of waste coals, and it's also very efficient, which means fundamentally the CO2 footprint is lower than conventional technologies. Added to that, we have installed a CO2 capture system, so we believe that we can be at near zero emission. And if you add in biomass and take credit for that biomass, you could actually be burning coal and biomass with a negative carbon footprint. So let's take a walk through the unit a little bit. This is the waste coal. You can see it's rather wet. We feed coal in with limestone and about 26% moisture, and it creates a paste, and that paste goes into the boiler. The reason that the moisture in this is valuable for this type of combustion technology is because we're operating in a pressurized mode. So after we burn the coal, we create pressure in the pressure vessel, and then we use a gas turbine to let down that pressure. The gas turbine spins a generator, and the moisture content in the fuel actually helps the mass flow through the gas turbine. We're going to be going up a couple of flights of stairs, and we'll get to the main operating floor, and we'll pause there for a moment and I'll show you what's going on. This is the pressure vessel right here. It's about 1 meter diameter, goes up about 80 feet. So this in effect is a vertical slice of a 100 megawatt module, 100 megawatt pressurized fluid bed boiler. This lower device down here is the natural gas burner. We use this burner to warm up the boiler, get it up to temperatures, and then we inject coal. We have one coal injection point. It's broken apart right now. We put a spool piece in there, and where that red bonnet valve is, that's our coal injection point. So once we start feeding in coal, we shut off the gas burner and we can sustain combustion on the wet waste coal that I showed you a moment ago. As I mentioned earlier, this technology was licensed by a company called PFBC EET. They're located here in the Pittsburgh, Pennsylvania area. And we think that this technology has great promise for its ability to burn the waste coal coming out of our coal cleaning process from our coal mines. Across Consol's system, we produce enough wet waste fuel to power about 1,000 megawatts worth of electricity. So that's certainly a resource that we ought to be using in the United States, using the wet waste coal rather than impounding it. So that's what we're working on and we're developing, and in several years we think we'll be ready to do a commercial plant. So let's move on now to our CO2 capture technology that we've installed on this PFBC boiler. We are standing in a building where we have a CO2 capture process. This process uses potassium carbonate to strip the CO2 out of the flue gas. Then the potassium carbonate releases the CO2, and we recycle the potassium carbonate to create a closed loop. Before we strip the CO2 out though, we first have to run the gas through a selective catalytic reduction device and in effect a SO2 polisher, so that we can remove all of the NOx, SO2, particulate out of the flue gas before we put the flue gas into the potassium carbonate cycle. And from this, we've been able to extract about 98% of the CO2 out of the flue gas, and the purity of that CO2 has been about the 98% level also. So with that CO2, then there are certain things that can be done with it. We can inject it in deep saline formations. CO2 can be used for enhanced oil recovery. We also did a very short demonstration where we took the compressed CO2 and we injected it in a water bath with algae to accelerate the growth of the algae along with a light source. So there's several beneficial uses of CO2, but probably to get down to the levels of reduction that are being contemplated in various bills that are going through Congress, we probably will be injecting CO2 into deep saline formations. The purity of this CO2 coming off of this technology will allow us to do that injection. David, I want to thank Power Engineering for coming by to visit us today. We hope you've seen some things, hope your readers have seen some things that piqued their interest. If they have questions or want more information, they can go on consolenergy.com's website. Just click on the Research and Development window, and you can get lots of information on various research projects that we have, work we do in our analytical lab, our metallurgical coal lab, and our PFBC pilot plant. So again, appreciate you coming by, and have a great day.